Okay, here's a problem which combines ideal gas equation with the sort of reacting mass calculation problem as well. Okay, so there's our ideal gas at the top left, ideal gas equation up here. And the main thing to remember with that is be really careful with the units, particularly the units of volume, which are in meters cubed, not dm cubed or centimeters cubed. And then obviously you've got to use Kelvin for temperature and pascals, not kilopascals, for pressure. Okay, so we've got magnesium nitrate. Magnesium nitrate, and it undergoes thermal decomposition to give magnesium oxide, which is solid, and nitrogen dioxide and oxygen. It says what volume of gas, so the total volume of the gas, so that's the NO2 and the oxygen together, will be made when 2.60 grams of magnesium nitrate undergoes thermal decomposition. Pressure 101.3 kilopascals, temperature 25 degrees C, and give your answer in centimeters cubed. Right, if you want to, pause the video and do it yourself and see if you get the right answer, and then see if you're working out it's right. Okay, so now I am going to give you the answer before we show you the working out. So if you've worked it out and you've got an answer of 1,701 centimeters cubed, well done, you've got the right answer. How do we get there now? Let's go through that. Okay, so first of all, we need to work out, we've got 2.6 grams of magnesium nitrate, but we need to work out how many moles that is. Well, the MR of magnesium nitrate is 148.3. So the moles of magnesium nitrate is equal to 2.6 over 148.3. That is equal to that is equal to 0.0175 moles, okay? Now we need to look at the equation to get the ratios, and we can see that 1 mole of magnesium nitrate gives us 2 moles of nitrogen dioxide and half a mole of oxygen. So we're going to say there then, so total moles of gas is equal to 0.0175 multiplied by 2.5, because that's how 1 mole of magnesium nitrate gives us 2.5 moles of gas. So that is equal to 0.0438. Now we need to use our ideal gas equation. Now we know everything except V, so we rearrange. So we get V is equal to, so we need to just divide by P, nRT over P. So that's going to be 0.0438. The ideal gas constant is, I should have given it up here, is 8.31. So at the top of the page anyway, isn't it? Now, our temperature is 25 degrees C. Need to convert that into Kelvin. So add 273 is equal to 298 Kelvin. So that's 298. And the pressure is 101.3 kilopascals. We need to convert that to pascals. So it's 101.3 times 10 to the 3. And this is going to give us our volume, which will be in meters cubed. So if we do that, so that is 1.071 times 10 to the minus 3 meters cubed. What do we need to do now? We need to convert that into centimeters cubed. So centimeters cubed, we need to times it by 1,000,000. There are 1,000,000 centimeters cubed in a meter cubed. So that is equal to 1071 centimeters cubed, and that's our answer. Okay, so well done if you got that one right. Let's do one kind of the going backwards for that. Okay, so we'll do one more. I'll just get rid of it. Okay, so we're going to go backwards. So the question says, what mass of calcium carbonate is needed to give 126 centimeters cubed of carbon dioxide? Okay. And the calcium carbonate is going to react with hydrochloric acid. So you've got CaCO3 plus 2HCl goes to calcium chloride, H2O, and CO2. And we know that the pressure, they tell us, is 101.3 kilopascals. The temperature is 25 degrees C. And the ideal gas constant up there, 8.31. Okay, so we need to, what we're going to do here. So we need to work out how many moles of carbon dioxide we've got from this. And then we can see in the equation there that 1 mole of calcium carbonate gives us 1 mole of carbon dioxide. So then we can work out the moles of calcium carbonate and then the mass of calcium carbonate. So if you want to do it yourself, pause the video and see if you get the right answer at the end. So right, here's our answer. So we need to rearrange PV, N, or T to give us N. So N is equal to PV over RT, which is 101.3. We've got to remember to convert it to pascals. Multiplied by, now we need to convert these into meters cubed, so we need to divide it by a million. So 126 divided by 10 to the 6. R is 8.31. 25 degrees C, that's 298 Kelvin. Just add 273 to it. And let's work out all of that number of moles then. Okay, so the number of moles is 5.15 times 10 to the minus 3. Now we'll say 1 mole of CO2, you need 1 mole of calcium carbonate to make that. So therefore, moles of calcium carbonate is equal to 5.15 times 10 to the minus 3. The MR of calcium carbonate is 100.1. So therefore the mass of calcium carbonate that we're going to need is going to be 5.15 times 10 to the minus 3 multiplied by 100, which is equal to 0.515 to 3 significant figures grams. Okay,